All right, we'll get back to section 2.5 here, and yeah, in this video, I'd like to finish up the section. We were just talking about absolute value equations, and now we'll turn our attention to absolute value inequalities. So there's a definition there. Next it says, let A be a number that's positive, and U be an expression involving x. Then the absolute value of U less than A means that if I want to solve for x and I lose the absolute value bars, U is in between negative A and positive A. U is an expression involving x. Okay? And the absolute value of U greater than A means that U is less than negative A or U is greater than A. Okay, so the bottom line here, whenever I want to solve an absolute value inequality, I must write down two inequalities. Okay, so I don't just forget about the absolute value bars and that's it, you know, because otherwise I only got half of an answer and that's a wrong answer. Okay, I need to get the complete answer. Okay. Now, if I want to break apart this compound inequality, I can if I wanted to, and I would write the word and. You know, so U is greater than negative A, and U is less than A. Now over here, I'm using the word or. There's a difference between the word and or, and we have to recognize that. Like if I have, like just to give you a real life example, suppose that I go to the ATM and get some cash. Okay. When I walk up to the machine, I need two things with me. I need the card and I need a PIN. Right? Now that's different from saying that you need a card or you need a PIN. Right? In fact, I don't think I'd like it if we had that system, a card or a PIN. Because if anyone got a hold of either of those two things, then they could access your money. So just as that word choice is important for what I'm saying there, it's important for what we're doing here also. Okay, now here's a way to remember and versus or and which word is going to be necessary to write down. So the first thing, well, regardless of whether or not I have an and or an or statement, the first thing I need to get the absolute value of U all alone and on the left. That's what I see here. Okay, so if I'm adding numbers or subtracting numbers, I need to take care of that, get the absolute value of U all alone. Then the next thing is item 2. It says if the sign is a greater than sign, and I'm going to purposely misspell the word or greater, I write the word or. And then item 3 would be, if item 2 didn't apply, if the sign is a less than sign, so I got the absolute value of U less than A, then, and I'm purposely misspelling the phrase less than, you're going to write the word and. Okay? So it's like kind of a neat play on words there to know which word you're writing down. So if you got a greater than sign, you're going to write or. If you got a less than sign, you're going to write and that's the word and comes from splitting apart the compound inequality. All right, so let's take a look at some examples of this. In this first example, what if I wanted to solve the inequality given by the absolute value of 3x plus 2 minus 6 less than or equal to 4? Solve for x. Well, if I add 6 to both sides, the absolute value of 3x plus 2 would be less than or equal to 10. Okay, so am I going to write the word and or? Well, I got a less than sign. Now here's a less than or equal to sign. But I still need to write the word and. Now the word and is going to come from a compound inequality. So I'm going to go ahead and lose the absolute value bars. I have negative A less than U less than A. So U is 3x plus 2. A is 10. So negative 10 would be less than or equal to 3x plus 2, and that's less than or equal to 10. Lose the absolute value bars. Okay, so we did that. And now the next thing is we can split the inequality, and we have to write the word and. So negative 10 is less than or equal to 3x plus 2, and 3x plus 2 is less than or equal to 10. Okay, then, by splitting the compound inequality, I can then focus on these two inequalities individually. So on the first one, I have to subtract 2 and then divide by 3. Negative 12 is less than or equal to 3x when I divide by 3. 3 is a positive number, so I'm not flipping any sign. Right? I only do that when I multiply or divide by a negative. It looks like x is greater than or equal to negative 4. Okay, and I do the same thing over here. So subtract 2 and divide by 3. So I got 3x less than or equal to 8. Divide by 3. 3 again is a positive number, so I'm not flipping any sign. X would be less than or equal to 8/3. Okay, so what we're saying is that x has to be a number that is both bigger than negative 4 and less than or equal to 8/3. All right, so here would be that statement written back as a compound inequality. Now, like any other inequality, your answer has to be written as a set or as an interval. You're not done with the problem until you have the set or interval written. Okay, so using set notation, I would say the set of all x such that negative 4 is less than or equal to x, which is less than or equal to 8/3. If I wanted to use interval notation instead, negative 4 to 8/3, just make sure there's brackets at both ends, right? Because you're including the endpoints there. Okay, either one of these two notations are fine. Okay, and that'd be the answer. Let's try another one here. Okay, so what if I wanted to solve the absolute value of 7x minus 1 greater than 6? All right, well, the absolute value expression is all alone and it's on the left. So I'm ready to apply the definition now for removing the absolute value bars. Now this is going to be an or statement, right? Because I've got a greater than sign. So here's the two inequalities that I'd be writing down. The first one is like pretending that the absolute value bars aren't even there. So I got 7x minus 1 greater than 6. Or then the other one is where I flip the sign and then throw a negative on the right. So 7x minus 1 is less than negative 6. And lose the absolute value bars. Okay, we just applied the definition for doing that. So on this first inequality, 7x minus 1 greater than 6, if I add 1, 7x would be greater than 7. And if I divide by 7, 7 is a positive number, so I'm not flipping the sign. X would be greater than 1. Okay. Over here, 7x minus 1 less than negative 6. If I add 1 to that, I got 7x less than negative 5. And then if we divide by 7, 7 again is a positive number, so I'm not flipping any sign. X would be less than negative 5/7. All right, so what we're saying is that x has to be a number that is both less than negative 5/7 or bigger than 1. So here would be that answer written as a set. So I'd say the set of all x such that x is less than negative 5/7 or x is bigger than 1. Or, and by the way, just before we go to the interval notation here, what would be wrong with saying this? So x is bigger than 1, right? Also, x is less than negative 5/7. So what would be wrong with writing it as a compound inequality? Well, that's not true, right? Because when you're writing it down like this, you're saying negative 5/7 is bigger than 1. That's not true, right? There's no negative bigger than 1. So something like this would be just flat out wrong, okay? the point is to say whenever we have the word or written, the word or has to remain in the answer. There's no other way around that. It has to be there, okay? So keep that in mind. The only reason why I said that is because I sometimes see students will write the answer as a compound inequality. You know, if they have an or statement, don't ever do that. Okay, you're saying something that's not true there. If we wanted to use interval notation, okay, anything less than -5/7 means I'm heading out towards negative infinity. Anything bigger than 1 means I'm heading out towards infinity, right? So the answer would be negative infinity to -5/7 or 1 to infinity. Okay, I got parentheses everywhere, right? Because I don't have any equal signs here. Now, I have the word or written. Okay, the union sign means the word or. So if you want to use the union sign, you can. Otherwise, or is only 2 letters, right? So I'm just going to write the word or. Okay. Yeah, so either one of these 2 answers would be my answer. And just pick one form or the other, you know, and whichever form you like better, whether it's set notation or interval notation to get the answer. Just make sure that when you solve an inequality, you don't just circle this part here. Okay, it's good. I don't have a set, or I don't have an interval then. Here's another example. So what if I wanted to solve the inequality given by the absolute value of 5 minus 5t plus 3 greater than or equal to 10? Okay, so if we subtract 3 from both sides, the absolute value of 5 minus 5t is greater than or equal to 7. Okay, and since that's a greater than sign, now greater than or equal to sign here, I'm going to have 2 inequalities where I lose the absolute value bars. Here they are. And so the first one is like pretending that the absolute value bars aren't even there. Or, that's a key word, right? Or. The other one, I need to flip the sign and then throw a negative on the right. So 5 minus 5t is less than or equal to -7. If we then solve these 2 inequalities here, okay, let's subtract 5. We got -5t greater than or equal to 2, divided by -5. We're dividing by a negative number, so we have to flip the sign. It looks like t is less than or equal to -2/5. Okay, or is a key word, so go ahead and write that key word again. Or yeah, do the same thing on the other inequality. So subtract 5 and divide by -5. So when I subtract 5, I have -5t less than -12, less than or equal to -12. And then if I divide by -5, I'm dividing by a negative number, so I must flip the sign. And it looks like t is greater than or equal to 12/5. So my answer has to be written as a set or as an interval. Okay, so using set notation, I would say the set of all t such that t is less than or equal to -2/5, or t is greater than or equal to 12/5. Okay, that would be the answer, and that's the only way to write that using set notation. Okay, I do not want to write a compound inequality because you're not saying something that's true then. Okay. If we wanted to use interval notation instead, that's fine. Okay, so anything less than or equal to -2/5 means we're heading out towards negative infinity. Anything bigger than 12/5 means we're heading out towards infinity. We're including these 2 numbers, right? So I'd have negative infinity to -2/5 with a bracket by -2/5, or 12/5 to infinity with a bracket by 12/5. Okay, infinity is not a number, so they will never have brackets by those symbols. Here's another example. So what if I wanted to solve the inequality given by the absolute value of 2x plus 1 less than -1? Okay, I want us to be as lazy as we can with this. I'm going to just go write the answer. We can go write the answer here because the left side is always going to be a positive number no matter what x is. X can be anything. And the left side is always going to be some positive value. The right side is -1. How many positive numbers are less than -1? None of them. Right? There's no positive less than a negative. So no solutions would be the answer. Okay? Now, if I take this example and I change it up slightly, what if I want to solve the absolute value of 2x plus 1 greater than -1? So the left side is always going to be a positive number. X can be anything, though, right? The left side with those absolute value bars is never going to be a negative. And so how many positive values are bigger than -1? All of them, right? All positives are bigger than -1. So all real numbers would be the answer to that. Okay. All right. So the homework in this section is on page 163. Be sure to look at those problems there when you get a chance. And now at this point, we're done with chapter 2. And so we'll get into chapter 3 a little bit in the next video.